Be looking what are direction cosines and what are their applications. So direction cosines are nothing but they are the cosines of the angle made by a vector with x, y, z axis. Let them we are calling theta x, theta y, theta z are the angles made them by the vector with x, y, z axis, and cos theta x will be the direction cosine, cos theta y, cos theta z are the direction cosines or cosines of those angles. So in this diagram I have made a vector. This is the vector and these are the x, y, z axis. So let's say we have to find this angle. Again, this is theta y. This is not in the back plane. This is not in the plane of paper. So this is in fact in this plane. Try to visualize. This is a right angle triangle. This is a right angle triangle at this point. So the vector is making an angle this with y axis. So how we can find theta y? Easily, if we know the magnitude of the vector as a, and we also know this length is nothing but ay. So by using a Pythagoras theorem, cos theta y is nothing but ay, which is base upon hypotenuse magnitude of a. Similarly, we can always write the other direction cosines as cos theta x is ax by magnitude of a, and cos theta z as az by magnitude of a. Listen very carefully. Now, if we have to find that what is the angle made by this vector with x-axis, let's say this angle is theta x. So we have to go by this triangle, and this will be the base, this will be the hypotenuse, and then we will be able to find out that what is the angle made by this will be right angle at this point. At this point. So base upon hypotenuse, again ax by az. So you need to visualize. Just look at my hand. Let's say these are the three x, y and z, and the vector is like this. So again the vector is not in the plane of x and y, neither in yz. So this angle, again this angle will be the angle between x and y, or the angle made by a vector with x-axis, y-axis and z-axis. Then it's quite difficult to visualize without having a 3D picturization in your brain. So these are the values we can calculate, and theta x, theta y, theta z are the angles made by these vectors with x, y, z axis subsequently. So what are the applications? Let's look at their application part. We can say cos squared theta x plus cos squared theta y plus cos squared theta z is nothing but 1. How? This will be ax square by mod of a square. Similarly, ay square plus mod of az square by mod of a square. So we can get as mod of a square, and upper part will be ax square plus ay square plus az square. As we already know, this is nothing but the square of the magnitude. So we get this by this as 1. Similarly, this is the first important point, and the second one, we can also replace cos squared theta by 1 minus sin squared theta. So 1 minus sin squared theta y and 1 minus sin squared theta z. They are nothing but cos squared theta z. All are replaced by like this will be 1. And when we take sin squared theta on these sides and 1 on this side, we get 3 minus 2 as sin squared theta x sorry, 3 minus 1, 1 was here, sine square theta x plus sine square theta y plus sine square theta z. So we get this as 2. So these are the two important relations of direction cosine. First one is this, and the second one is sine square theta x, sine square theta y, sine square theta z is 2. We'll look at a question involving direction cosines. There is a vector which makes an angle 60 with x-axis, 45 with y-axis. So this might appear strange to you that 60 plus 45 is not 90. So it's not needed. A vector can make any angle with x and y-axis. The sum of that should not be 90. That will be 90 only if the vector is in xy plane. Okay. So 45 with y-axis, and we have to find the angle with z-axis. So using cos square theta x plus cos square theta y plus cos square theta z, we can get 1. By putting the values, we are getting cos square theta x is cos square 60 plus cos square 45. You must know all these values. Cos square theta z equal to 1. This is nothing but 1 by 4 plus 1 by 2 plus cos square theta z as 1. So we get cos square theta z as 1 by 4 and theta z as cos theta z as plus minus half. Similarly, theta z can be 60 or 120 degree. So these are the two values possible for theta z. Again, cos square theta z is 1 by 4. So cos theta z may be plus or minus half. So we are getting two values for theta z as 60 and 120. So theta z can have two values, 60 or 120. The second part of the question is demanding that what is the vector if it is a unit vector. So as we already know, ax is ax by magnitude of a is cos theta x. So we can say ax as magnitude of a into cos theta x. In this case, it will be magnitude of a is 1 as it is a unit vector, and cos theta x is half cos 60. Similarly, ay will be cos theta y, and we get ay as magnitude of a into cos theta y as 1 into 1 by root 2. Similarly, az will be 1 into 1 by plus minus 2, as we are getting two values of cos theta z. So the vector a cap will be nothing but half I minus 1 by root 2, plus 1 by root 2 j and plus minus 1 by 2 k. This is a unit vector, and if the magnitude of this vector is nothing but if magnitude of a is 5, we can just multiply these components by 5, implies the vector a will be 5 times half I cap plus 1 by root 2 j cap plus minus half k cap. Just take care of this plus minus, it's very important, and there will be two values of theta z. Just take care of that. Thank you.